Mathematics is the silent language of the universe, a language that transcends borders and cultures, speaking to the very essence of reality itself. It's the framework upon which reality is built, the invisible scaffolding that holds our world together. From the swirling galaxies in the vastness of space to the intricate dance of subatomic particles, math underpins everything. It is the thread that weaves the fabric of the cosmos. We might not always see it, but its presence is undeniable. Look around you. In every interaction, every structure, every piece of technology, mathematics is at work. The buildings we inhabit, the bridges we cross, the phones in our pockets, they all exist because of mathematical principles discovered and harnessed by brilliant minds throughout history. These principles have been refined and perfected over centuries. Imagine a world without numbers, without shapes, without logic. A world devoid of the mathematical principles that guide our understanding. A world where trade is impossible, where structures crumble for lack of sound design, where technology never progresses. Such a world would be chaotic and unrecognizable. It's a bleak picture, isn't it? A stark contrast to the ordered and logical world we know. Mathematics is not just a subject confined to textbooks. It is, in essence, the very fabric of our existence. It shapes our reality and influences every aspect of our lives. But the story of math is not just about cold, hard logic and abstract concepts. It's about the human spirit and our quest for knowledge. It's a human story, a testament to our relentless curiosity and our burning desire to make sense of the world around us. This journey has been marked by moments of profound insight and discovery. It's about the ancient civilizations who first etched numbers onto clay tablets, laying the groundwork for future generations. The Greek philosophers who pondered the mysteries of geometry, pushing the boundaries of what was known, and the modern-day mathematicians who grapple with concepts that boggle the mind, continuing the legacy of exploration and discovery. In the following sections, we'll embark on a journey through the annals of mathematical history. We'll trace the evolution of mathematical thought and its impact on our world. We'll uncover the origins of this fascinating subject, exploring the early contributions that set the stage for future advancements. We'll explore the groundbreaking discoveries that reshaped our understanding of the universe, from Newton's laws to Einstein's theories, and delve into the philosophical questions that continue to challenge and inspire us, questions that drive us to seek deeper truths and greater understanding. Our journey begins in the cradle of civilization, where the seeds of mathematics were first sown. In these fertile lands, the very concept of numbers began to take root. Imagine the bustling marketplaces of ancient Mesopotamia, filled with the sounds of bartering and the sights of diverse goods. The land between the Tigris and Euphrates rivers, a region that nurtured some of the earliest human civilizations, where the Babylonian civilization flourished over 4,000 years ago. This was a society that thrived on innovation and knowledge. Here, amidst the clamor of traders and the murmur of scribes, a revolution was brewing, a numerical revolution. The Babylonians developed a sophisticated system of mathematics driven by the practical needs of their time. They were pioneers in the field of arithmetic and geometry. They needed ways to keep track of trade, to survey land, to predict the seasons. Their solution? A system of numbers based on 60, the remnants of which we still see today in our minutes and seconds. This sexagesimal system was revolutionary and highly efficient for their calculations. These early mathematicians used cuneiform script, pressing wedge-shaped marks into clay tablets to record their calculations. This method of writing was both durable and practical, ensuring their knowledge could be passed down through generations. Imagine the feel of those cool, damp tablets, a stark contrast to the sleek digital screens we use today. Yet, these ancient tools were the cutting-edge technology of their time. Meanwhile, on the banks of the Nile, another great civilization was making its own mark on the world of mathematics. The ancient Egyptians, renowned for their monumental architecture and intricate hieroglyphics, also possessed a deep understanding of numbers. They used a decimal system, similar to ours today, and developed sophisticated techniques for surveying land and constructing pyramids with astonishing precision. Their architectural feats continue to amaze us to this day. Their papyrus scrolls, filled with elegant hieroglyphs, serve as a window into their mathematical minds. These documents reveal their advanced understanding of geometry and arithmetic. These early civilizations may not have had the tools and technologies we take for granted today, yet their contributions to mathematics were nothing short of groundbreaking. Their work laid the foundation upon which all subsequent mathematical discoveries would be built. Their clay tablets and papyrus scrolls, though silent now, echo with the ingenuity of those who came before us. These artifacts are a testament to the enduring legacy of early mathematicians. As civilizations rose and fell, the baton of mathematical exploration passed to the ancient Greeks. They inherited a wealth of knowledge from the Egyptians and Babylonians, but they were not content to merely preserve it. Instead, they sought to expand and refine it, driven by a deep curiosity. and a desire to understand the world in a more profound way. The Greeks' approach to mathematics differed significantly from their predecessors. While earlier civilizations used mathematics primarily for practical purposes, such as commerce, astronomy, and engineering, the Greeks saw it as a way to explore abstract concepts and uncover universal truths. They were not content with merely using math as a tool for practical purposes. They sought to understand its underlying principles, its beauty, and its profound connection to the universe itself. This philosophical approach to mathematics was revolutionary and set the stage for many of the advancements that followed. They transformed mathematics from a set of practical techniques into a rigorous and abstract discipline. This transformation was driven by a desire to seek out the fundamental truths that govern the natural world, and to express these truths in a precise and logical manner. Think of Pythagoras, whose name is forever linked to the famous theorem that bears his name. Pythagoras and his followers, known as the Pythagoreans, believed that numbers were the essence of all things, and that the universe could be understood through mathematical relationships. He wasn't just interested in calculating the lengths of triangles. He saw in them a reflection of cosmic harmony, a manifestation of the divine order of the universe. This belief in the mystical and philosophical significance of numbers was a hallmark of Greek mathematical thought. His work, and that of his followers, laid the groundwork for the development of geometry as we know it. The Pythagoreans' emphasis on logical reasoning and proof became a cornerstone of Greek mathematics. Euclid, another towering figure in Greek mathematics, took this abstraction a step further. He systematized the knowledge of his time and presented it in a clear and logical format that could be easily understood and built upon by future generations. His monumental work, Elements, is a testament to the power of logical reasoning. In its pages, he laid down a set of axioms, self-evident truths, and proceeded to derive from them a vast body of geometrical theorems. This method of starting from basic principles and building up a complex structure of knowledge was revolutionary. In its pages, he laid down a set of axioms, self-evident truths, and proceeded to derive from them a vast body of geometrical theorems. Elements became a cornerstone of mathematical education for centuries, a testament to the enduring power of Euclid's logical framework. It was used as a textbook for over 2,000 years, influencing countless mathematicians and scientists. The Greeks' contributions to mathematics extend far beyond geometry. They delved into the properties of numbers, exploring concepts such as prime numbers and irrational numbers. They also made significant strides in understanding the nature of infinity and the continuum. They explored the world of numbers, grappled with the concept of infinity, and laid the groundwork for the development of algebra. Their work in these areas laid the foundation for many of the mathematical concepts we take for granted today. Their legacy is immense, shaping the course of mathematical thought for centuries to come. The methods and principles they developed continue to be a source of inspiration and a foundation for modern mathematics. Their relentless pursuit of knowledge, their insistence on rigorous proof, and their unwavering belief in the power of logic continue to inspire mathematicians today. The Greek architects of logic have left an indelible mark on the world, one that continues to resonate through the ages. Our journey now takes us eastward to ancient India, where a revolutionary concept was born, the concept of zero. It's hard to imagine a world without zero, isn't it? After all, zero is such a fundamental concept, so deeply ingrained in our understanding of numbers, that its absence seems almost unimaginable. But for centuries, civilizations around the world made do without it. They had no symbol for nothingness, no way to represent the absence of quantity. Then, sometime between the 4th and 5th centuries CE, Indian mathematicians gave birth to this revolutionary idea. And what a revolution it sparked. Zero wasn't just another number. It was a placeholder, a concept that allowed for the creation of our modern decimal system. With zero in their arsenal, mathematicians could now express vast numbers with ease, opening up new frontiers in mathematics, astronomy, and commerce. The invention of zero, coupled with the development of the decimal system, marked a turning point in the history of mathematics. It paved the way for the development of algebra, which flourished during the Islamic Golden Age. Arab scholars embraced Indian numerals and algebraic concepts, developing new techniques for solving equations and pushing the boundaries of mathematical knowledge. Their contributions, preserved in beautifully scribed manuscripts, spread throughout the world, influencing mathematical thought for centuries to come. Don't forget to like, subscribe, and share this video.